And welcome to this video on long-run equilibrium. And in particular, we're going to be discussing an example with regards to long-run equilibrium. So we're gonna start. Suppose we have a typical firm which operates in a perfectly competitive market and has a long-run cost given by this function q cubed minus 4q squared plus 8q. And we assume that the firms in this industry have identical cost functions. Further, we assume that the market is at constant cost industry. So if you recall, when an industry is at constant cost industry, the entry or exit of new firms, okay, does not affect the input costs, which renders our long-run market supply curve to be horizontal at the unique long-run equilibrium market price. Okay, so even if we have new firms to enter, that will not really change the market price because the input costs have remained fairly unchanged. And furthermore, currently, the market demand in the industry is Q is equal to 1000 minus 100p. And suppose that entry and exit are allowed. So our first question is that how much output will each firm produce in the long run? Okay, so since the problem assumes that the market is at a constant cost industry, again, that entry of new firms does not affect the input prices, then the entry and exit of these new firms will leave a typical firm's long run cost unchanged. So this long run cost here is going to be relatively unchanged when new firms enter the market. Therefore, as new firms enter, the long run marginal cost and the long run average cost will be left unchanged. So in long run equilibrium, okay, our condition is that in long run equilibrium, okay, equilibrium, it must be that P is equal to LMC is equal to LAC. And that condition is required by the first order condition for a maximum profit and the profitability criterion. So this is our FOC. Then we also have our SOC, which is that the first order derivative of LMC over dq with respect to Q is greater than 0, which is an SOC for a maximum profit. And this condition necessarily requires that the output produced by a firm is such that the condition of LMC is equal to LAC is satisfied. So we have our long run cost. So if you recall, your long run cost is equal to Q cubed minus 4Q squared plus 8Q. Okay, and we know that your LMC is just the derivative of your long run cost with respect to Q. So you have 3Q squared minus 8Q plus 8. So that's LMC. Then LAC, okay, so LAC is just equal to LRC over Q. So that's going to be equal to Q squared minus 4Q plus 8. Then what we're going to do is we're going to equate the two. Okay, we're going to equate the two, and that gives us, so LMC is equal to LAC. So LMC, that's 3Q squared minus 8Q plus 8 is equal to Q squared minus 4Q plus 8. We have a plus 8 on both, so we can take that out. Then we have 4Q here. Then we have 2Q here. Sorry, 2Q squared rather. Then you can divide both sides by 4Q. 4Q. Okay. And that yields us, let's see if I did this correctly. So, if you can solve, so let's simplify it a bit. So this is going to be equal to, so this is going to be 1/2 Q is equal to 1. Then if you take this out, multiply both sides by 2, you'll find out that Q is equal to 2. Okay, so Therefore, at long-run equilibrium, each firm will produce a quantity Q is equal to 2. Okay. Now, that's the FOC. We need to go now to the SOC. So the SOC requires that D LMC over DQ. Okay. And if we solve for that, we just take the derivative of this one with respect to Q again. So that's going to be equal to 6Q minus 8. Okay. But we know that Q is equal to 2. So this is going to be 6 times 2 minus 8. So that's 12 minus 8. That's equal to 4, which is greater than 0. And that condition is satisfied because remember our SOC requires that the derivative of long-run marginal cost with respect to Q should be greater than 0. Therefore, both the SOC and the FOC have been satisfied. And to answer the question, each firm will produce 2 units, okay, in the long run. So that's for each firm. So let's move on to the next question. Okay, what is the long run market equilibrium price and output? So since long run equilibrium, so we said that long run equilibrium requires that P is equal to LMC is equal to LAC. So if we substitute, okay, the Q is equal to 2. So we know from before Q is equal to 2. If Q is equal to 2, we can substitute that to either your LMC or your LAC equation. Substitute, say, to LAC, but technically you can do it for LMC too, since they're just equal. We find that LAC is equal to 2 squared minus 4 times 2 plus 8. That's equal to 4. Therefore, P is equal to 4. Okay, that's the market price. And the long run, okay, the long run market equilibrium output, okay, using can be derived using the market function that we have, using the market demand function. And the market demand function, if you recall, that's Q is equal to 1000 minus 100 times P. So this was the function that was given. So if we plug in 4, so that's 1000 minus 100 times 4. That leaves us with Q is equal to 600. So in this market, the long run market price is 4, while the long run market equilibrium output would be 600. So if we have this data, we can also analyze how to do question 3. And question 3 asks, how many firms are there in long run equilibrium? Okay, now, since all firms in the market have identical cost functions, okay, they must have identical output supplied as well. Okay, since these firms have identical cost functions, it implies that they have a similar output structure, so they must have supplied the same output. Therefore, the total long-run equilibrium market output, okay, that's Q star is just equal to F, or the number of firms, times the output supplied by each firm, okay? Therefore, if we since we want to find out the number of firms, so this is number of firms, okay, we can just isolate out the formula. So F is equal to Q over big Q, or your market quantity, over your firm quantity. Your market quantity is 600, and your small q, which is the firm's, what each firm will supply, is equal to 2. Therefore, it suggests that F, or the number of firms in the market, is equal to 300. So we have 300 firms in this market. So this is an example of long-run competitive equilibrium. And in another part of the video, we're going to discuss a continuation to this problem wherein we prompt a scenario wherein the demand curve shifts. So see you in the next video, and thank you for your attention.